Hello everyone, how are you all? Welcome back to the SCHEMATIC Education. I hope all are you good and learn something new in every video. I mean to say, you will enjoy the learning journey, right? Today we discuss about charging circuit of iPhone. I mean to say iPhone charging circuit. How charging circuit work in a iPhone. As you will all see in thumbnail, right? One of our subscriber named Nalin Densiaka. Oh, I hope I'm pronouncing his name well, right? He says, "Sir, make a video on iPhone circuits." So here it is. This video about iPhone charging circuit basic structure. I hope you like this video. Now, one thing you will notice that what is written in my T-shirt. It's motion creates momentum. So what does that meaning? Motion create momentum. For my according, it's if you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. Whatever you do, keep moving. Keep moving in your life. Keep moving in your learning stages. Always keep learning if you want to achieve your dreams. So, what is the meaning of this sentence according to you? Motion creates momentum. Tell me the comments, right? So, let's start the video. Let's go to the schematics. How iPhone charging circuit work. I hope you all like this video and tell me this sentence according to you. Motion create momentum, right? Got it? Let's move the video. Now, for the charging circuit, I am opening the Borneo. In Borneo, we open the component section. In this section, you will see the charging IC name, right? All detail about the charging IC, how many IC and what are the names and working, right? Also the diagram, basically schematics, layout section. So in this section you will find the component location, right? And the bitmap for helping. Clear? So you can better understand. That's why I'm opening each and everything on iPhone 6. Basically, I'm choosing iPhone 6 model because this is the basic model, and in this model you will be able to understand very well the name of lines, also the how the charging circuit works. If I'm choosing the latest model, then perhaps it would be difficult for you understand the circuit. So for the startings, I have chosen the basic models, iPhone 6, right? So you can understood easily, right? So first of all, iPhone come to you for a charging issue, no charging or any charging problem issue. So first thing you do, you clear the charging port, or you can, I mean to say, you clean the charging port. For most of the time, you will see garbage, or you can say dirt, gets accumulated in a charging port in an iPhone, right? You first thing do, clear the charging port properly, clear the dirt, garbage from it, and wash it from the thinner or alcohol, whatever you use in a phone repairing, right? First thing, clean it properly, the charging port, right? After, you will see the other step, or you will do the other steps. First thing, clean the charging port properly. Now in second step, open the phone, I mean to say disassemble the phone, and remove the charging flex from the main board connector. So this was the main board connector. Here charging flex connect it. So remove the charging flex from there. After, you will check 5 volt on a charging flex on both sides on a connector, right? On a meter, on a multimeter, on a voltage mode, connect the charger. Clear both probes, red and black, and both sides. Put the both probes on a charging flex on this connector, on a charging flex connector. So you will get a 5 volt right? If you get 5 volt on charging connector, that means on charging flex, that means your flex or charging port is okay. If you did not get, first clean the charging port properly, or second replace the charging flex. So this is the basic steps I'm trying to tell you step by step, because there are many people who don't know any knowledge or any idea about these phones. How do these phones check or measure voltages? How to tracing, right? But some people also in this channel have the advanced knowledge. For advanced knowledge, I mean to say they learn only a charging circuit, or you can say a charging IC, how charging IC work. They know also the how the basic things work, but some of the people don't know how the basic thing works. So how do they check? So for this, I'm trying to tell you in a full details, in a every step, how you can check each and everything. For those people who just here watch the charging circuit, I want to say be patient. We will move on to the charging circuit step by step in this video, right? Now, if you get 5 volt here, that means your charging flex is okay. Now check on the motherboard connector. Sometimes this connector, motherboard connector, is dry solder, right? Also sometimes does not connect, I mean to say loose some points, waterlogging, or any reason a charging flex connector not connected properly here, or this connector not connected the motherboard properly for any reason. That's why the charging circuit does not work. So how do you check this connector is connected properly? First thing, multimeter on a diode mode, right? Black probe on this point. This is the positive point. This was the ground point. You can ground red probe on here, also here, right? After measure a value or diode value here, you will see a diode value from 300 to 550 according to your multimeter. If you get here, it's okay. If you get beep or 00, that means sometime this line internally short. Now the diode value is okay. Measure the voltage. Let's first we go to the schematics. On layout section, first copy the connector. So just this was the motherboard connector, a charging connector, copy it and paste in diagram. And next and zoom. This was the main motherboard layout again, and next. Now this was the J1870 charging motherboard connector. So the both ends, one end is pin number 13 and 40 and 42 called PP 5 volt USB, the main positive point. In iPhone you will see for PP 5 volt USB. In Android this line called, I'm already told you in a previous video. Tell me, what is this line called? V bus, voltage bus, right? Remember? It better be. So this point is the ground. For checking, you just copy this point, right? Now this point connected all these pages, right? We'll see all these pages. Check the one by one. How can? Just next. Now this line first goes to the some capacitor, or you can say multiple capacitor. For this, you will just copy any one of this capacitor and paste in layout where the location is this capacitor. So you can measure the 5 volt. Just next. Now zoom out where it is. This capacitor on other side of the motherboard. I will show you in a main motherboard. So this was the main motherboard, right? This is our CPU, our network section, right? This was the whole network section. I will explain you in another video. First, in this video, we will talk about just charging circuit. Now just, where is this capacitor? On other side. This is the bottom side of the motherboard. Now you will see this capacitor, right? you will get 5 volt here. But it's difficult to measure 5 volt here. Why? Because this is the other side of the motherboard. I mean to say bottom side of the motherboard. So for this, you will just remove the motherboard or open the motherboard from the middle, right? Also, you will remove this shade for checking, right? For this, back to the schematic, and let me check on another side diagram. Now check any one of these capacitor. Let's see C1812. Copy this and same paste in layout, and next. Now this is the, where is this capacitor? Zoom. Now you will see near the battery connector, or you can say near the charging connector of first component, C1812. Now in this main motherboard location, you will see this is our main charging connector. So this component, you will see this component, you will get 5 volt here. If you had difficult to measure this on this component, now let's see on next, where you can check a V bus, PP, USB 5 volt. You will get 5 volt here, right? Now when you put the flex on the main motherboard, right, when you connect the charger and put the flex on the main motherboard, it's difficult to check here also, because the flex cover almost this area. So your multimeter probe does not connect properly. So how do you check? For this solution, just back to the schematics. Now copy this line again, and next. Now this line connected to the main, again connector. Now same connector. Now next. Now this line goes to TP, or test point. Clear? Now you can check or measure in this test point for 5 volt. Now where is this test point? Just copy this and paste in layout. And next. Now where is this? This TP 2501. Just little bit near the battery connector. So I will show you in a component section. Now on a main motherboard. So this TP, right? You will check on this TP for 5 volt. How can you check? Put the flex, charging flex on the main motherboard connector, right? Remove the battery after you can check with the multimeter on a DC voltage mode. Connect with the charger. You will get 5 volt, right? If you check with the battery attached to battery, you might be confused, because you will see the battery voltage here. If you connect the battery, for this I am saying disconnect the battery. After connect the charger, and you will measure here for 5 volt. If you get 5 volt here, that means your charging flex, your charging port, or this motherboard charging connector, all are okay, right? Problem in motherboard area or motherboard section, right? If you did not get 5 volt here, right, that means problem in maybe a charging port damage or not clear, right? Maybe a charging flex damage, or this connector. I will show you. This connector not connected properly, or maybe a dry solder reason, maybe a water logging reason. That means this connector not connected properly. So first you check for the diode value. For the shorting, you will get 300 to 500, 550, sorry, diode value. Again, you will check for the 5 volt here. If you did not get on a TP test point 5 volt, sometime you will see this connector for the reason. For this, if you get on a charging flex 5 volt and does not get on a TP, that means 100% this connector had a problem. So replace this connector or solder it properly, soldering properly, right? Now, if you get 5 volt on a test point, the problem in a main motherboard, right? So we will trace on a main motherboard. I'm giving you all details, full detail, step by step. How do you check? Because most of the people are fresher here. They don't know about how to measure or how to check each and everything. That's why I'm giving you each and every step detail. Right? For those people who waiting for the charging IC, wait for some time. Your brother who don't know anything about this circuit, they also write the option for the knowledge. They also want the knowledge for those, right? I hope you get my point. I will give you all knowledge, all detail in this video. Be patient. It will be okay for you. Now you will get TP. I hope you can understood. If you get on a 5 volt on a TP, that means your charging port, your charging flex or these connector are okay. Otherwise, work on 3 areas. Let's see where else this line going. Our voltage line, USB 5.0, or this back to the schematics. Now this TP. Now next. Now this line goes to the another page. In this page, you will see voltages 1.8, 3.0, 1.8, 3.0, 1.85 volt, like this PP 5 watt USB, voltage 5 volt 0, right? USB to PMU, voltage 5 volt. BP buck, switching LXO, 4.6, 1.8 volt. PP codec, 3.0 volt. PP ALS connector, front cam VDD, 1.2 volt. That means this page you will see the line names and the voltages, right? This is a nice thing or good thing on a iPhone schematics. Whenever you're confused on which line on whenever you're confused on how much a voltage on this line, you will see this page, and after go through this page, your confusion will be clear on which line had how much voltage. Like this PPV2 R cam connector, right cam connector, voltage 1.2 watt. So here all the voltages mentioned along with the line names. So that is I think that is a good data collection given by the iPhone schematics. So next after this line goes to the AIC. Which IC is this? U1202. Now just copy this IC and paste in layout. First, which IC is this? Let's say U1202. Now a rectangle shape IC just above the NAND. Now go to the component section. I know that which IC is this, but for you I'm looking on the component section. So right, this was the NAND and this was the power, our power IC, right? Main power. So this USB line connected to the main power. I will show you. Get back to the schematics. Now you will see a VBus line, USB to PMU. This line name USB to PMU, right? PP 5 volt USB. And for the power, inside the power name, this line called USB to PMU, means from charging connector to PMU means power controller, main power controller. Also you will see the buck coils connected to the buck lines. These buck lines connected to the CPU from other side, from switching here, and the LDO section, right? LDO 6, 2, 4, 5, right? So power IC generate buck lines, also the LDOs. I'm already told you in a previous videos. So this line connected to the power IC. Now there is resistance 1201 470 ohms, and no stuff. No stuff means there is no resistance available in a motherboard. In Android you will see NF, not fitted, or NC, right? In iPhone you will see no stuff, right? Now again click this line. Where else is this line connected? Now next this line goes to the another IC. Which IC is this? You will see a PMID, boot cap. That means this is our charging IC. Now where is this IC placed? Just for copy this and paste in layout. After I will explain to you. Now next. So just slightly down the NAND, I will show you. You will see this IC, charging IC, right? Now get back to the schematics. Now before I will explain to you this IC, how this IC work. First let us know where else the PP USB line connected. For this again copy this line and next. Now this line we connected the another page in a MOSFET. You will see in a MOSFET connected the drain point, right? So gate connected with the resistance connected with the ground, 10K resistance. That means this MOSFET is the P-type MOSFET, right? Now source, the other side of the source connected to the another line. Where is this line connected? Let me see. PP TriStar pin, copy this and next. Now this line goes to the another IC. Which IC is this? U1700. So this is our TriStar IC, right? Let me see where is this place size. Just copy and then layout in zone. You will see just little above the charging IC. On a main motherboard, you will see this, the TriStar, right? Now I will explain to you what about the TriStar. This is basically the we call host IC or U2 IC in iPhones. TriStar IC, U2 IC, or you can say host IC. When you connected the phone to iTunes or 3U tool through DP and DM, this IC, basically this IC create the port. I mean to say help to connect you with the PC or laptop, your phone, through this IC. Now this IC also working as a OVP, over voltage protection IC. I will tell you now. See this pin number D6, gate enable. Now follow this line. Now in this line you will see a test point. Also in this line called TriStar to PMU OVP switching enable, right? Now click this line and next. Now where is this line going? On this line connected to the our charging IC, right? First USB to PMU 5.5 volt line connected to the MOSFET, right? P-type MOSFET, and on a source point through MOSFET another line connected to the TriStar IC, basically working as a OVP IC. Through OVP IC a signal generate called OVP off, VBus OVP off off and given to the charging IC, right? You might be confused all the structure, how the structure works, because most of the, you can say, Android and iPhone are different circuit, working difference, right? That's why iPhone circuit are complicated. I will explain to you, don't worry. Now, before I will explain whole circuit, first we go back to the same line and check where is this line also connected, which page. Now again MOSFET, now multiple caps, we also see this page. This is the charging port, also see same TP or data page, PMU, right, charging IC and MOSFET. So almost this line connected to the 6 to 7 points, right? So you might be confused, right, how this circuit works. Now this was the MOSFET, right, a P-type MOSFET. If you want to know about MOSFETs and what is MOSFET and how it works, the MOSFET uses in laptops, mobiles, mostly electronics component devices, right? Now how many type of MOSFETs, how they work, how to test, if you want to know, then comment on this video, right? Then I will make a video, a separate video for the only MOSFETs, in a detailed video for you, which MOSFET is a fully explained, so you can understand what is MOSFET and how MOSFET work. If you want, then comment this video. Also, if you might be confused in this line, I will explain to you everything, right? How this charging line, basically a charging line, in Android we call this line PP USB 5 volt line, we call VBus line, or in iPhone we call USB, right? So how this line works step by step, I will explain to you with a diagram. So don't worry, you will understood in an easy way, right, how this line work. So let me draw first these pages, how this line connected to each other, so you can understand easily. Now I will tell you this line PP USB 5 volt line, how this line connected with the charging IC, or how this line work with the diagram, so you can better understand how this line work. On schematics you might be confused because this line connected so many points, but when you looking the diagram on a step basis, you will understood much better way how this line work, right? So let's make a diagram. Now in front of you there is a diagram. This is the charging connector on the motherboard, right? This was the charging IC. When you connect the charger, the charging port, or you can say when you connect the charger, the charging flex connect here, put it here, right? But when you put the charging flex here, the charging flex almost cover this area, right? So in this point you will get 5 volt here, right? This point was the ground, connected with the ground. So how can you measure on this point, because your multimeter probe does not connect properly on this point when you put the flex on this connector. This line connected to the first charging IC, remember it, through charging connector this line connected to the charging IC. Now how many steps or before the charging IC, how this line react or connected other lines, I will tell you. Now first this line you will see a TP test point. In this line, in this point you will get 5 volt. Connect the charger, put the charging flex on this connector and measure the 5 volt here. I will show you on a motherboard. So this was the motherboard. On this connector, you connect the charging port, charging flex, and you did not measure here 5 volt because the charging flex cover it all. So you can measure on this TP. If you get here 5 volt, that means your charging flex, your charging port, also this charging connector, these all are okay. So first step, you will check 5 volt on this TP. Now after the TP, next step, what is the next step? Now let me show you back to the diagram. Now after the TP, this line connected with the multiple balls on a charging IC. I will explain to you later. Now after the TP, this line connected with a MOSFET. Remember, first you will get 5 volt here after the TP. After this line connected with a MOSFET on a drain point, right? This was the drain point. On this point you will get 5 volt. The source connected with the ground with a 10k resistance for the negative signal. So this was the P-type MOSFET, right? So this MOSFET is always on, right? Now the source pin connected with the another IC called U2 IC or TriStar IC in iPhone. In Android we call you can say OVP IC, but iPhone this was the call U2 IC or TriStar IC, main host IC. Through this IC, right, your phone connected to the iTunes for the flashing or downloading purpose. Clear? Most of the time this IC was the damage in a charging issue. When you replace with the new one on a U2, the charging issue resolved. It's not like the Android you can bypass it. You will replace. How this IC work, I will explain to you before we will go to the schematic and I will show you. Now next, this was the MOSFET, right? The gate pin connected with the 10k resistance and ground. The drain pin you will see connect with the PP USB line. On this line you will get 5 volt. Now the source pin connected with the U2 IC. Now next, just a second. Now click this line and this line. On this capacitor you will get 5 volt, right? Now this was the U2 IC, the host IC. I'm already explained to you. Through this IC, enable signal goes to the charging IC. Looking at this, pin number D6, power gate enable, TriStar to PMU, OVP switching enable, right? Click this line and next. Now this line goes to our charging IC 1401, right? PMID, boot cap, switching coil. So this was the charging IC. Through this line, our charging IC sends U2 IC is okay or not. If this line was the damage, charging IC does not enable. Right? Now this charging IC also called Tigris. Right? Now let's back to the diagram. Now this line also called the TriStar PMU OVP enable. Through this line, charging IC activate. So in the schematics, first I will tell you, you might be confused how this line check. So a normal procedure, you will first get on the TP 5 volt, after you will check this MOSFET, after you will get the U2 IC. Also the measure the this capacitor, last capacitor near the charging IC on this line, PP USB 5 volt for 5 volt. So these are the steps before entering the charging IC. Now after I will explain to you how charging IC work. Hope you get my point. Right? Now after the diagram made, it's easy to understand how these line, how this circuit work. Got that? Let's move on to the charging IC, how charging IC work. Now this line connected to the charging IC, PP 5 volt USB, I mean to say VBus line. Now you will see this VBus line connected to the charging IC. Pin number A5, B5, D5, C5 and E5, right? After this voltage, right, connected to the charging IC, charging IC generate another voltage called PMID. I'm also told you in a previous videos in Android charging IC, also in a Samsung circuits, about this PMID. Now in Android you will see a one cap in this line, right? Now in iPhone you will see the multiple caps, 1, 2, 3 and 4, but there is a no stuff. That means this cap is not available. Other 3 caps you will see available in a circuit, right? Now in these caps you will see 5 voltage, right? Now first let's see where is this cap. Now let's see where is this cap in a motherboard section for copy and paste in layout. Next, now just above the charging IC, now in main motherboard, where is this? So on the bottom side. So this was the charging IC, just this cap, also this cap. These caps installed in PMID line. In these caps you will get 5 volt, right? Let's draw it first, after I will explain to you more about this PMID. In diagram you will see the MID cap, this cap. After the PP USB 5 volt enter this line, enter charging IC generate the PMID voltage. In Android you will see the only single cap, or in iPhone you will see the multiple caps, right? But I made in a diagram a single cap because there is less space, and I will draw another lines. That was the reason I'm only made a single cap. So all these caps are important in schematics. If you remove any one of these caps, your charging IC create a problem, some like fake charging, right? Here on this cap you will get 5 volt. I'm already explained to you in a previous videos charging related, my another videos, right, on a Redmi basis like BQ series, also the Samsung, right, Samsung charging IC. How this cap work, what are the important of this cap, right? Basically you will get 5 volt. If you get 5 volt here on this cap, what does that mean? That means this whole line from charging port to charging IC, this whole line completely open, connecting properly with voltage if you get 5 volt here. But in the iPhone, you will see this MOSFET, right? That doesn't mean this line completely attached with the U2 IC or this MOSFET. That only means this whole line from charging port or charging connector to charging IC, this whole line or 5-volt line are completely okay connect with the charging IC. Now, suppose there is a near about a cap, you will get 5-volt here, and you did not get 5-volt here. What that mean? That means some of the reason this line or any one of, because this line connected the multiple points, I'm already show you in schematics. Maybe the some reason any line does not connect with the any pole. For water logging, reason behind the water logging, drop down case, right? Any reason somehow this line not connected properly internal in the IC. First reason, if you did not get 5-volt here on this cap. If you get 5-volt on this cap, last cap on this line, and did not get 5-volt on this line. First reason, this. So, and second reason, your charging IC is faulty, right? So, how you check it? Just open this IC from the motherboard, check these line where this line connected these balls. Suppose this line connected to this board. Check the continuity on between both of the points. Each and every line, because this line connected to the multiple balls, every ball you will check with the continuity mode on multimeter. If you get a beep, then it's connected properly. Your fault on a charging IC. If any reason, any ball does not connect, your fault create. So make a jumper from one ball to another ball. I hope you will understood what I'm saying. Here, second reason, your charging IC fault. But if you get 5-volt here, that means a good news is this whole line. Your charging port is okay. Your charging connector is okay. This whole line completely attached with the charging IC. Problem is somewhere else. Now next line. For next line, we go to the schematic again. Hope you like it. The way of my teaching and enjoy it. For this, get back to the schematic. Now in a diagram. Now after the PMID, right? You will see this whole structure in Android similar. If you already see my previous videos, if you already follow me, you know that how this circuit works. Because I'm giving you complete detail already in previous videos. Now some people says, sir, why are you teach in a particular model? My answer is, I'm always said in previous videos, don't look at the model, which model comes to your repair, which model comes for repair. Don't look at the company, look at the IC, which IC install, which IC on your work, right? Because the basic fundamentals are mostly similar. The basics things are similar. If you learn basics, half work you will done. That's why I'm always working on your foundation, basics. I'm always teach you through basics, because I always say keep learning, keep improving yourself. Now, strong your basics. After when you strong your basic concepts, doesn't matter you work on a lower model or latest model. You will learn easily later circuits if your basics are strong. Right? That's why I'm working on your foundation, on basics. Because if your foundation is strong, your building will never collapse. Even you built many floors on it. But if your foundation are weak, it does not work on your foundation, right? Then maybe a single floor collapse. I hope you get my point. So don't afraid how iPhone work, how latest ICs work. Update yourself and improve your knowledge. Plus, work on the basic concepts. If your basics clear, then you work on a latest phone easily. I hope you get my point. Now let's do the next line. Now PMID clear, VBus clear. Now after that, this boot means on a G5 a boot cap. Through this, on this line you will see a capacitor. One side connected with the IC and other side also connected with the IC. A4, B4, D4, C4 and G5. First I will draw, after I will explain to you. Now after this, another line, right, comes out on this IC. On this IC you will see a capacitor installed in a series, both sides attached with the charging IC, right? Now this capacitor called boot cap. You already see in Android videos, right? Same as like Android boot cap. You will have both side diode value. Both side a different diode value. Somehow one side you will see 350 and other side you will see 500, right? Depend on your multimeter. But on a voltage board, one side you will get 3.7 to 4 volt. Other side you will get 6 volt to 8 volt. I hope you get my point. Same, I'm already explaining in previous video. If you don't know about this, go and check out the previous video and strong your basics, right? If this cap removes missing or damage, your IC does not work, because this cap has an important role of the switching your phone on a dead condition. This is a very important cap called boot cap. You will see in Android phones, also in an iPhone. One side you will get 6 to 8 volt, other side you will get 3.7 to 4 volt. Right? I hope you get my point. Clear this line. Now where is this cap? I will show you. So for this, go to the schematics and Borneo and just copy this cap 1402, capacitor 1402, and paste in layout. Next, now zoom out, right? Just near the CPU, also the basement CPU 1402. I will show you in a motherboard. Where is this? On the other side of the motherboard. This cap is a boot cap. You will get both side diode value. Mostly cap you will see in a parallel line, right? One side you will get ground or beep, other side you will get a value. But this cap connected both sides to the IC, right? One side connected to the VPH coil, other side connected to the IC, and this VPH coil also connected to the IC. So this cap connected with a serial, right? Like this. So suppose this was the IC and this cap, right? Hope you get my point. Let's see another line. Now after this line, you will see this line on the other side of the capacitor. In this line you will see a coil, a switching coil. On Android we call VPH coil. On this line goes to the like this, right? I will show you, right? I'll explain to you how this line works. So this line, one side first capacitor, one side after that coil, and this line goes to the, I will show you, this line called VCC main in iPhone. In Android, this line called VPH or V system. Remember, I'm already told you the basics. Keep your basics strong. V system. In iPhone you will call VCC main, right? So first let's draw it. After I will explain to you more about this line. Now another line connected to the, this cap means this line connected to the, this IC. On this IC you will see a coil. Also this line called VCC main, right? In Android we call VPH or V system. Now this line goes to the many sections, like your network section, right? Audio section, right? Graphics section, light section, Wi-Fi. Most of the sections need main voltage, right? So this is your main voltage. If you know about VPH, then you will understand easily. If you don't know about the VPH, just go and check out the previous video, primary and secondary line. You will understand this concept. VCC main, similar as a VPH, V system, with this VCC line. Clear? Now, if this coil damage or open, your IC does not work, your IC does not create VPH, right? Will tell you your phone on a dead condition, because when you connect the charger through charging IC, VPH or VCC main create through this line. Clear? Now next we go to the back to the schematics, or if you want to show where is this coil, near the boot cap, already I will show you, right? So just get back to the schematic first. Now back to the schematic, right? Now this line also connected to the same IC. You can say this line goes back to the same IC, called VDD main, right? VDD main. This line called VCC on when this line connected to the after IC VDD main. In Android, same we call V system or VPH. I will show you when I draw, you will understand easily. For this, just draw in a schematic, draw in a diagram. Now a line comes out from this line and goes back to the same IC called charging IC, like this IC, right? In this line you will get 3.7 to 4.2 volt. you will check any one of in this line capacitor. I did not create any capacitor. Reason there is less space. The more lines comes out of this charging IC. So, right now in this line you will get 3.7 to 4.2 watt. On Android you will see same line get back to the IC called V system or VPH. Right? Now next get back to the same IC. Sorry, schematics. Now follow this line. Now in this line you will see a MOSFET. Right? Right? Now one line connected to the source of the MOSFET. Right? I will draw. After that I will explain to you. Right? This line connected with the VCC main in this line or MOSFET. The source point connected to the MOSFET. Clear? After that another line from the gate get back to the, or you can say connected to the charging IC. Right? This line called, I will tell you in a schematics. For this get back to the schematics. First you will remember this line connected to the source pin on a MOSFET and a one line get back to the charging IC. Now you will see the source pin connected to the, this IC was the multiple pin IC. Suppose 1, 2, 3, 4, 5. Sorry, 4, 5 pins. These 5 pins are all same. One pin connected to the gate and 3 pin connected to the another line. Which line is this? I will tell you. Now a line. In this line you will see no stuff. There is no resistance. Direct connected to the charging IC. Now on this line you will call ACT diode, means active diode, charging active diode. To this line charging IC control this MOSFET. How this MOSFET work? Why are this MOSFET here? I will tell you. First you will understood. Next line, after that I will explain to you. The next line you will call BAT, right? From A1, B1, D1 and C1. Right? And this line you will see multiple capacitor. So this line goes to the PP BAT VCC. This line goes to the battery connector from charge the battery. I will draw you after I will explain to you this line. Now another line comes out from the IC. Right? PP BAT VCC. This line goes to the battery connector. First I will explain to you this MOSFET. Now the drain pin connected to the PP BAT VCC. Now in Android you does not see this MOSFET because I'm already told you this MOSFET already installed in a charging IC, inbuilt in a charging IC. That's why you did not see it. Now how this MOSFET work, I will tell you. Now when you connect the charger, first you will get 5 volt here PMID. After the boot cap, switching, right? So when you connect the charger, VCC main, right? Or you can say RVPH or VCC, right? created by the charging power, right? Also through this MOSFET a line goes connected to this and charge the battery, or same time charging the battery, also working on a charging power, the whole phone, right? Your whole phone process working on a charging power when you connect the charger, right? Through this line, gate line, charging IC sense and active the MOSFET, right? But when you disconnect the charger, right, on this line you will get a battery power, because this line connected to the battery. Through this MOSFET, VCC generate the battery power, I mean to say VPH generated by battery power, right? When you connect the charger, VCC generated by this on a charging line. Also some voltage give it to the PP VBAT line to charge the battery. But when you disconnect the charger, your phone shift to working on a battery power through this line. Hope you get my point, right? This MOSFET controlled by the charging IC. Your charging IC know when you connect the charger or not, so it's enable the MOSFET accordingly. Hope you get my point. Let me show you in now first where is this MOSFET and this line connected. So this going to the schematics. I hope you get my point and understood what I'm saying to you. Just a second. Now this was first this PP VB BAT VCC. First you will see where is this MOSFET. If this MOSFET was weak or does not work or damaged, right, your phone dead, because your phone does not work on a battery. The battery power does not create the VPH, right? Hope you get my point. But there is a minimum reason, or right, this MOSFET does not work. Now where is this MOSFET? Just copy and paste, and now you will see near the charging IC, this 9 pin, right? I will show you in a diagram, sorry, main motherboard. So this was charging IC. This you will see this was the IC, but this was not a IC, this was a MOSFET, right? 5 pins similar, suppose this like this, 5 pins connected with the 1 pin, right? 1 pin for the gate, 5 pin for the source connected to the VCC line, and 4 pins, or sorry 3 pins connected to the drain, yeah, means battery line. Hope you get it, right? So be careful of this small IC, or you can say MOSFET. This was the MOSFET, right? In schematics you will see this was the MOSFET. 1 2 3 4 5 8 and 9 pins working like a MOSFET, look like a IC, but internally this was the MOSFET. Basically a 3 pins, but you will see a 9 pins, right? Get my point? Now clear? Now where is this line going? PPVB is VBAT VCC. Now next, now you will see this line connected to the with capacitors, right? the battery connector. Battery connector. So I will draw you first, after I will explain to you. Right? So this line connected to the battery connector. When you connect the charger, I'm already told you, your phone working power shift on a charging IC, on a charging line, right? But when you disconnect the charger, your phone shift to on a battery power through this way. Through this way, your phone charge, right? On this way, your phone, when you connect the charger through this way, your phone working on a charging line, charging power. Also through same line, your phone charge at the same time. You most of the time you will see when you connect the charger, your battery increase plus you will operate the phone. Both are working on the same time. But when you disconnect the charger, this line through battery power line, your phone operates through this MOSFET. Your MOSFET controlled by this charging IC. Hope you get my point.